And welcome back. Now today I was going to do a video on this little device here, which I thought, oh, this could be useful for us all, because it's a replacement power supply for a different one you can normally get that's usually quite okay to use. But of course this comes from China. It uses mains voltage. Those two words in a single sentence without the word not in between can put people off. So I thought I'm going to get one, well in fact two, so I could take it apart and just see if it's going to offer us any value. Whilst that was going on, I also had this demagnetizer ordered because I was fed up with my screwdrivers picking up screws when they weren't supposed to, but sometimes it is useful to do that. And I've also got these solar panel connecting strips, I suppose you call them, for a very specific purpose, not least of which it refers back to Benny's cat run rain sensor. But as I say, I was going to do a video on all this, and I still will to some extent, but there was a little comment that pertains to this. This is mains, and as we know, mains is all very dodgy. You know, you really shouldn't be touching mains if you don't really fully understand it, because it is lethal. Even in the United States, they might have, I think it's like 115 volts, plus or minus. That is also lethal. In the UK, 240 volts, kill anything, never mind you. So yes, we have got to be careful. And as it so happens, I was admonished by a viewer about an offhand remark I made in one of my previous videos. In fact, let's just have a look at that. I'm sure you won't mind me showing it. Right, so it's this comment up here by Whitefields 5595. Hello, thank you for your comment. Now this comment has in fact been edited a number of times since it first appeared, because I was told to go and stand on the naughty step. It was that bad, he thought. And so I've been sitting on the naughty step all night, and it's where I'm actually doing this video from, would you believe, because he hasn't said I can get off yet. But as I say, he's edited it since then. But what the essence of this is, and you can read it in your own time just by pausing the video, what he's saying is that when I was doing the video on the logic analyzer, I was sort of, well, not confusing exactly, but glossing over earth, ground, common, possibly even chassis connections, I don't know. But anyway, he's saying if you get this wrong, you could do yourself some serious damage, and that's absolutely true. So let's go back to the workbench and we'll cover this topic in a little bit more detail when we get to this device down here. A few things that perhaps a little bit more light-hearted in a sense. Right, this thing here, demagnetizer, magnetizer. You may have one in your toolbox already. If you don't, you really should try and get one, because they are very, very useful. What do? Well, as the term is written on here, it magnetizes and demagnetizes your tools, like screwdrivers. Now, that's all very useful if you want to pick up little tiny screws, perhaps, with your screwdriver, right? So what you do, you just put that in the hole and drag it out the other side, and as if by magic, this is now magnetized. In fact, I'm going to get a screw and show you exactly that. And as if by magic, some screws have appeared down here. Well, I say the word screws. Let's get this right as well. These aren't screws. Screws are what you put into wood. These are, in fact, little nuts and bolts, okay? Oh, look at that. It's very highly magnetic. So, having magnetized this screwdriver now, if I touch one of these things, absolutely nothing happens whatsoever, because it's not been magnetized enough. Let's try that again, shall we? So, stick it in there, take it out, and ta-da! Right, so it's stuck to it. Now that's all very well. In fact, let's do it with the bolts thing, because if you're trying to get this bolt aligned in a hole and you want to put it in just right, obviously this is the wrong screwdriver for this bolt, but let's just assume you did. You could hang it on there and then drop it in, and that's fine. However, if you then want to screw stuff up that you don't want magnetized, you've actually aligned the bolt yourself. For example, let me put my big clumpy hand in the way. So this is now aligned in a nice little screw hole. You come here with a screwdriver, and before it can really get into the slot of the screw, it grabs it and drags it out the hole. I've had this happen many times. So what you then need to do is demagnetize it. So what you actually do on here, in fact, I did it the other way around. So what happened is we put it in here and then drag it out the other side. Now what that should do, no, that didn't work. In fact, I had to do this 2 or 3 times. I can't remember if I did it like that and then out. Yes, there we are. Look, it's very weak now. If you want to magnetize your stuff, that's easy to do on these. Just stick the thing in the hole, demagnetize it. Slightly more tricky, but once you've done it, you just have to take my word for it. When you do it right in here, I can't remember now if I pulled it all the way through or just put it in, then dragged it out again. It does demagnetize it properly, and then it won't pick up these screws. That one still does, obviously, so I haven't done it right. And there it was. That was a UK supplier, but I'm sure you can get them just about everywhere. Now then, what's this? These are solar panel connection strips. Now, if you've ever seen a solar panel, you'll find that they are connected along the actual shiny, glossy bit across the top with these things. They're very thin, very bendable, and they're soldered very easily on the panel. And the point is, of course, being on solar panels, they have to withstand the weather, don't they? Which is exactly what my rain sensor didn't do. If you looked at the video that's now on screen, you'll see that it corroded before I made some amendments to it quite heavily. So these are cheap, easy to solder, and do not corrode. So you could put 2 of these, for example, in a plant pot, just as an example, and to measure the moisture content, and they wouldn't corrode after a week or 2 like other stuff does. You know, even copper goes funny, and certainly standard wire will. These, however, don't. So I just thought I'd share that with you because I'm going to be using those. Right, now let's get on to the meat of our video. So I saw these on AliExpress. Now these are the equivalent, I suppose you'd call it, of a wall-wart plug-in transformer. So you put the AC in one side and you get, well, in this case, 5 volts out, as you can see there. But you can get them 3.3 on AliExpress, but they do them in all sorts of voltages. The brand, I couldn't find them on AliExpress, but you can get 7.5, 12 and so forth. And I thought, well, being small and compact, that could fit into a project rather nicely to power anything Arduino wise. But of course, yeah, knowing the Chinese design and mains electricity, I thought, am I setting myself up for failure? If you look at the video that's now on screen where I did have a plug-in wall-wart and that eventually burnt out. That was supplying my CCTV camera, and eventually that all disintegrated inside, and well, obviously it burnt, probably caught fire inside. Luckily there was no area in there, so it went out again, but I mean that could have been disastrous. Luckily the CCTV camera survived, so I'm a little bit wary of buying anything from the Far East and that are connected to mains. Now the reason I was interested in this, because I do have a different type of well, AC supply to DC that looks a little bit like this one. Now these are cheap, high-link, they're reasonably well thought of, almost identical as you can see to this one in shape, obviously different colour, but I'm thinking, is this just a cheap knockoff, or is it built at least to the same specification of the high-link one? Now the high-link one, does it conform to, well, European CE standards? Now if we scroll down a bit on here, it might tell us. Yes, you see here it says meets the requirement of UL, whatever that is, and CE. Now CE should stand for Conformité Européenne, which is the French for European conformity, okay, standards, electrical and otherwise. However, CE also stands conveniently for China export, which basically means nothing at all. It means we've exported it from China. So when you see a product that has the CE stamp on it, you have to be very careful whether it's the official CE stamp, Conformité Européenne, or whether it's just China export. And the placing of the letters is very important. Basically the C and the E, they're curved. They should in fact meet only as circles, like this one on screen now. And if it's some kind of fake, or at least, you know, it stands for China export, not CE, then it probably looks like something like this. Easy to mix up, and of course, well, easy for us to get duped into buying the wrong thing. So taking this with a large pinch of salt, then I thought, right, let's get another one and take it apart. So I've just managed to get it out of the case. And I thought, right, I'll stop there so you can sort of follow me through. One of the things I'm not going to do at the moment is connect it up as is. So let's, as you can see, first of all, it was jammed in here and it had a lid on it, this one here. So the wires went through some of these holes, and that was easy enough to get off. Just a screwdriver down the side. Then you had all this, I don't know what you call it, potting compound, I suppose. Sort of a rubberized, well, protective layer. It's just to hold it steady, I think, in the thing. It comes off pretty easily. So I guess the next thing to do is take all this gunk off, expose all the circuitry so we can have a closer look. Because the first thing we need to know is, if AC is coming in on these two terminals, have we got at least safe distance between these and the rest of the board? Because that's the first thing in the CE code. There's got to be, you know, a surrounding distance around here to keep the mains away from everything. Even if that is true, though, this is obviously meant to be mounted on some kind of printed circuit board, possibly strip board. I don't think I'd feel safe connecting this up to any kind of strip board, actually. So in some ways, its appeal has been diminished a little bit to me, because if you mount this on your circuit board, it means your circuit board immediately becomes potentially at mains voltage, doesn't it? And that could be, well, a recipe for disaster, really, anything with mains on it. Whereas the alternative, of course, is to use a standard wall-wart, plug that in, and then you just got 12 volts or 9 volts or something. You plug that into your project, Bob's your uncle. Anyway, let's just pursue this for a minute, take all this grey gunk and see what we can find out what's underneath it. Right, here we are back on the workbench, and I've taken off as much of this grey stuff, this potting compound, that I wanted to. There's still some on here, as you can already make out, but I thought, well, if I try and take any more off, it's definitely going to destroy something. Now, the layout of this board is almost identical to the HLK-PM01 that it, well, does it copy it, clone it, whatever. The layout is almost identical. And you just caught me actually trying to do some simple resistance tests, but frankly, if it had failed this, I think even the Chinese market would have rejected it. So that's pretty simplistic. So let me just disconnect those off there. That was that was checking the resistance between the input and the output to see if they were totally isolated. And I think generally we can say yes, they are isolated. Does it conform to standards though? Well, that's an interesting point actually. This is the live input here, the two AC inputs. There is in fact a gap there. If I put my finger behind, you'll see it perhaps. There's a gap. Oh no, it's covered by, what's it covered by? A component. Well, that sort of destroyed that then really. You're not allowed to cover gaps like this, bridge them. And there's supposed to be something like a 3mm gap here that I'm not sure that really conforms. Basically between the incoming mains live wires, so the line and the neutral, you really should have 3mm, and there should be 5mm between either of these and anything else on your board. So there's got to be a little tiny area, if you like, a bit like a force field, you know, 5mm away. Well, I don't think this really cuts the mustard there, because as you see between here and here there's not 5mm, although that might all be part of the live circuit. Certainly the input comes in on those two long prongs now, straight into that, which is a bridge rectifier, and then sort of disappears underneath this transformer. The long and short of it is, would we trust this? Well, as I say, thousands wouldn't trust anything that comes out of the Far East with the word mains on it. But I do know that thousands of people use these quite successfully. And given that it's an embedded piece of electronics in this box, if anything went wrong, are you protected in any way from it? Well, you might be, because it's all plastic and everything. Your poor little piece of equipment might not be. And let's just think about what the worst that could happen. If one of the live input wires were to somehow become attached to the output wires, these two long ones here, what would happen apart from frying your Arduino? What it could mean, of course, is that the circuit which you're working on suddenly becomes live. Now, if that's in a plastic box, you may not notice, but if it's not in a plastic box, if it's in a metal box that you've earthed, then most certainly you would notice, and hopefully the earthing of the chassis would protect you from a potentially fatal shock. That and your RCD on your mains input, of course, residual circuit detector. I don't know about this though. I mean, I'm not qualified enough to figure out whether I'd actually use this in my circuit. I know that the HLK-PM01 is used by thousands, hundreds of thousands, perhaps even millions of things are out there using it quite successfully. This is a clone as far as I can tell, but is it a clone that's been built down to a price and therefore cuts a few corners? Don't know. I'd probably try it out, but one of the things, as I said though, is that if we look at the unadulterated one, is that because these pins are obviously expected to go onto some kind of printed circuit board or something to hold all this steady, it sort of negated its potential benefits really, because if these were screw-in terminals, for example, on the side, you think, yes, I can isolate those nicely and keep the mains wires away from anything else. But as these have got to be soldered, now of course you can solder the wires on here with some nice insulated heat shrink on them. So you could have your flying leads on here soldered going off, and then these two could be soldered onto your board and perhaps a blob of glue on here just to hold it all nice and steady, and it'd work. But I think it's a compromise, and in some ways I'm a little bit dubious now about using this. I do have an HLK-PM01 somewhere. I was hoping to dig it out just to show you, but frankly it looks just like this. Now what they do say on the internet, I've had a look at the Arduino forum briefly. What they're saying is if you really want safety, you need something like this, which has been certified safe. So the standards that are required, the British standards, well the European standards in fact as well, have been met and tested for, you know, gap between the live and resistance and breakdown voltage and stuff like that. But then of course you're talking, as it shows you here, look, £7.30 including that. That's quite expensive, isn't it? You can probably buy a fairly decent plug-in wall-wart for that and have all the safety you need, because you've still got to plug in something somewhere, whether it's a mains lead or whether it's a low power 12 volt or 9 volt lead to the wall-wart. So, and also not only that, this device, they say, oh yeah, we do a little adapter. Oh, here it is. Look, there's the picture. So not only have you got to buy this item itself, you then buy this board to make it super safe. And of course the cost is just climbing and climbing, isn't it? But at least this one, if you need this for a project, this one at least has been certified as being safe, but the cost is relatively high. But this one, I'm really not sure about. I hesitate. This one, I bought it quite a while ago now, and I've heard good things about it on the internet as being tested and safe. It probably says once again it's certified somewhere. Meets the requirements of the UL and CE, whatever that means. Doesn't say which standards it corresponds to, does it? Let's talk about what we originally came into this video with now, with this comment, quite right too, about the ground and earth, because if this did go wrong, either one of them, and the mains input was somehow connected to your circuit, why do you get a shock, and why is it such a big deal? And this may surprise you, but your earth wire in your house, so that's all the European setup and certainly the States as well, the earth is maybe not quite what you thought it is. Let's have a look. So let's think a bit more about mains electricity, grounding and earthing, and how that can protect us. Now let's assume we have our little Arduino project built over here. It's built in some kind of box. We'll assume that for the demo purposes here, this is in fact a metal box, so it's got a chassis of some kind around it, and your Arduino and all the gubbins is in the middle. and this is being powered then by this device. So let's bring that device out of here just for a minute. Remember that it's a coil, so the mains is coming in and 5 volts is coming out, and all right, yes, this is rectified and smooth and whatnot and goes back in dry, do we know? But we'll just quietly forget about what's happening in that little bit and just bring it straight back in. Fine. Now, because this is all this now is effectively inside your case, we're going to assume that this is now going to be earthed. So because you're bringing mains in here, so your line and neutral, you're also going to bring an earth cable in and connect that somehow onto your chassis. That would be good practice, best practice, and could indeed save your life, right, in case something went wrong here. At the very simplest level, if this line wire here became loose and touched the case, you would become electrocuted if you touched the case and this wasn't earthed. As it is, it's earthed. Electricity would not flow through you. It would flow immediately through the case as soon as it touched it and go back to earth, and hopefully blow a fuse or trip your residual circuit breaker or something like that. Great, super. Think about what's happening though before this, and this is the bit that some people find a little bit odd, is that the electricity coming into your house is effectively a big version of this. Now, in the States, you often have transformers up a big long telegraph pole with lots of big fat electricity wires running on them. But in the UK, it's not like that. Our electricity is delivered to us normally underground from a little substation box not so far away, and there's various houses all connected to it. But the principle is exactly the same. Somewhere there's a transformer, and let's draw this here. So this might be very high voltage. I mean, this might be a kilovolt, could even be 10k. I don't know how many times it gets transformed down from those big long pylon things, but let's assume this is 1 kilovolt. Okay, it doesn't matter. And then the other side of this, in the UK at least, is going to be 240 volts. And arbitrarily, one of these is designated line, one of them is designated neutral. It might be the order of the windings on here, because remember these two windings never touch, it's all done coupled by electromagnetic forces. So one's line, one's neutral, and normally you have an earth, and that's the bit that confuses people. But we'll come on to that in a minute. So the 3 wires in your, meter cupboard in your house, or whatever it is that supplies your electricity in your house. So here we have the live, which is connected to that, the neutral to that, and the earth is going to be connected to that, normally by a plug of some sort. That's fine. The interesting bit, though, is that the earth is quite often connected to the neutral, like that, just inside your meter cupboard box or something like that. And you might think, what's this? Well, that's exactly what happens a lot of the time. And even if it's not connected inside your meter cupboard like this, somewhere along the line, it might be that this neutral wire here is tapped out and the earth brought out to your house like that. But it is, without a shadow of a doubt, connected to the neutral of the electricity board supply. This neutral is also connected to a big pole in the ground like that. And in your house you would then have an equivalent version of that. So your earth inside your meter cupboard, if we assume that this is your meter cupboard or supply box or whatever, the earth in there would also be connected to the ground. But this is unusual, I would say, in the UK. Maybe farms have it, I don't know, some remote places. But certainly in the UK, you'd either connect the earth to the neutral inside your meter cupboard, or it might run a separate wire back somewhere along the line and connect to the neutral of the electricity board's neutral supply. So if we think, well, the earth is effectively neutral and neutral is effectively earth, how does it now protect us? Well, the reason it protects us back in our Arduino world is that if this live were to ever connect to the chassis, as we said before, if that were to connect to that, therefore connection isn't being made to the neutral now, remember, it's through here, but we're not worried about this. This is what happens normally. But if that live were to touch the casing, which is connected to earth, that goes down here, and and eventually, somewhere along the line, gets connected back to neutral. Now, in your house, undoubtedly you have a fuse on here, which we can draw as a fuse symbol, which is something like that. So the fuse would blow, or even better, there'd be some kind of residual current detector here, and it says, well, what goes out there has basically got to come back in there, in that direction, and if it doesn't, it means it's gone somewhere else, basically down to Earth. Now that could be through you. Imagine, for example, there was a break in the Earth, like this little gap here shows, and you're standing here, and you just happen to touch that case there. Well, what would happen then is the live will go around the case, touch you, and from you go down to Earth, because you're standing on something, and it doesn't really matter in a building whether you're standing on the actual ground, the earth you walk on, or whether it's just the building itself, because that itself is probably earth with lots of metal pipes being earth themselves, all bonded together. So anyway, the current would flow through you, and you only need something like 30 milliamps, just slightly more than 30 milliamps, and your heart would stop if it went across your heart. So your residual circuit, residual current detector here will trip as soon as there's a mismatch here of anything like 30 milliamps or above that. Now sometimes these can be a little bit prone to tripping when they shouldn't, especially with older properties, and you can get higher values ones, but for the main part, plug-in ones, and the one I've got on my wall, for example, in my next to my meter cupboard, it will trip at 30 milliamps, and it doesn't trip normally, only when you put water inside a light switch or something, or stick your finger in a socket, then it would trip. So it's interesting, is it not, that the Earth is connected somewhere along the line to neutral, and the neutral is connected down to Earth at the electricity board site. We don't really worry about that too much. So if this little device that we're talking about now were to actually blow up, so if this were to go wrong, which is what we're worried about, of course, isn't it, the fact that there's AC inside here, if by some mischance it were to melt or blow up, and this live were to be somehow connected to this side here, because these windings have got hot and they've melted, and all the enamel has burnt off, and now they're connected like this, then of course your Arduino would immediately become live potential, and you wouldn't want to be touching any of this. So hopefully the fact you've earthed the chassis means that at least the box inside this is protected. So if you were to touch the box, you're okay. Your Arduino, unfortunately, would not survive this, of course. It's not going to survive 240 volts going into it. The long and short of it is, by earthing the chassis, you're protected from this live ever contacting here, or if it's shorted out like this, and your Arduino becomes effectively live potential, then you're protected because the chassis is protected. But don't go poking about inside boxes that are still connected to the mains. It's just not a good idea, especially if you're considering using something like this. And it's not just because this is made in China. Effectively, it doesn't matter what transformer arrangement you can have, they can all go wrong. And this is one way of protecting yourself. The windings, incidentally, are normally on some kind of ferrite steel core or something like that. And quite often this whole transformer arrangement, not this one in here, I hasten to add, but a standard mains transformer, big one, that could also be connected to Earth, primarily, I think, because of the protection, so that if something did happen with this, the core itself would provide some level of conductivity protection down to Earth as well. But anyway, there we are. That's what it's like. We certainly want to earth any chassis, and always make sure you've got an RCD in your house, and certainly a fuse, but a fuse is not going to stop you dying. All right, it might protect the rest of the house, but that's about it. This RCD, though, will certainly protect you, and it could even protect your equipment, so let's not skimp on that. Now, all this talk of line voltages and ground and everything and all the rest of it made me think, hang on, there must be something on the internet that explains this a little bit more succinctly, and I wish I'd found this page 10 minutes ago. If we look at the Wikipedia, of all things, there's the page on ground, And it does in fact display a couple of images and, well, certainly describes a lot of things that we've been talking about. This, for example, here is a ground stake or rod that goes into the ground connected to this earth wire. What else does it talk about? Well, it talks about ground and earth and all this. Now there's an interesting little bit further down I just saw. I'm going to put a link to this page on the video description. Now this is talking about electronics. Now what this is saying is, of course, you've got different grounds. Grounds basically are just, well, the reference point to whatever your power supply is connected to. So in a battery, the plus is the line voltage equivalent, so that's your positive supply, but the other end, commonly known as the negative, is in fact the ground reference to that power supply. But you can connect that positive battery supply to anything else, and no current will flow, will it? It's got to go back to the end of that battery, right? Could. Right. Now, what else does it say here? Well, one thing to note, in fact, is that signal ground, chassis ground and earth ground, they're all ground in the sense that it's relative to what you're supplying the power to, I suppose you call it, to, from. But only one of these is earth. Earth is only earth if you're connecting it to the earth you walk on, the round ball, the planet we know as Earth. If it's not connected to that by some route, then it's most definitely not Earth, but it most definitely is going to be ground, because otherwise the current wouldn't flow. And it's, oh yeah, so here we are, that's circuit ground versus Earth. That's probably a good read. Yeah, okay. It talks about, oh yes, one thing that's useful, not necessarily in Arduino world, but it might be. It says the signal ground may or may not be connected to power ground. And indeed, what happens in audio amplifiers, for example, you will have a signal ground that is totally separate from the power ground until it all meets back up at the sort of transformer end or the smooth power supply end. In fact, you have a sort of a star connector there so that you don't run all the grounds into one wire at the end of it. That's why you'll get interference and hum and all sorts. So you have two entirely separate paths for the signal ground to go back and the power ground to go back, because as you can imagine, as the sound or music is being generated, the power supply, it becomes very noisy. You know, there's lots of up and down movement on that power supply, even if it's very well stabilized. We're talking, you know, a few tens of millivolts maybe. But the signal ground does not want the signal ground to move up and down relative to the input. So that will be a separate wire back, and then it's all connected together back at the power supply. Yeah, that's Benny's just telling me to mention a couple of things here. Okay, well this is probably a good read. It's you know, background reading. It'll take you 5 minutes to whiz through that, I would think, to be quite honest. But this all leads us back to, does it not, about whether we're going to trust this or not. Oh look, I found my high link, by the way. There it is. And it looks, look, you see, it looks identical, doesn't it? Even underneath and all that, you know, looks identical. So whether this is the clone or whether it's a replacement, I don't know. You could probably use one of these for years to come and it will have no trouble at all. But as my plug-in wall-wart shows you, these things do fail sometimes due to poor components or poor quality or poor assembly, or I don't know what it is that causes them to fail. But if you want safety, then you really will have to go to that certified version like this. But then you've got to ask yourself, is a plug-in wall-wart for £5 or $7 not a better deal anyway? Okay, well, if you found this video useful, do give me the old thumbs up. And okay, here's a question for you then. Would you, having explained what I've explained now, would you use one of these? Or would you think, no, I wouldn't touch them with a barge pole? Let me know. Put a comment down below and go, wouldn't touch them, or yeah, I'd use them, no trouble at all. Be interesting to find out. Okay, thanks for watching. See you in the next video. I hope you're finding these videos useful and interesting. There are plenty more videos to choose, and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.